Good morning. On Thursday, we did row reductions, right? And what a massive pain they were. We're now going to start using row reduction. Solve systems. So here's the general idea. This is the matrix form of a system of equations. A times x equals b. A is your coefficient matrix. Each column of A represents one of the unknowns. Each row represents an equation in the system. X is just your vector of unknowns. B is what's known as your constant vector. Right, so normally what you did when given this system, right, is in algebra you just do the method of elimination. You try to eliminate as many of the unknowns as you can, and then do backward substitution using your operations that give you equivalent systems. If instead we work in matrix form, set up the augmented matrix, A augmented with B. Now you have two choices here. First is the REF. This is your standard method of elimination. You would then have to do backward substitution. This method is called Gaussian elimination. The other option is now to RREF it, which is without a doubt the superior method. This will require no backward substitution. This is called Gauss-Jordan reduction. I will wind up using both methods for the first problem, and then just stick with Gauss-Jordan.
How did they figure out that matrices help solve system equations?
Someone smarter than me. they kind of just realized, oh, why don't we just try and put in an array and see how that works? Because they recognized 3 by 3 coefficients. You kind of recognize, that's an array. Can we do something similar? They defined row reduction, and they realized that, oh, the row operations are identical to the operations on systems of equations. And from there, probably just said, okay, let's see if this works. Thankfully, it did, because this makes solving equations a hell of a lot easier and more efficient.
So then what was the original use of matrices or matrices?
Probably just storing large data of information. Make it easier to recall. That was probably their original intention with arrays. And then realize their usefulness. System of 3 equations in 3 unknowns. This is a 3 by 3 coefficient matrix. I won't always do this, but I will write it out for this problem, the actual matrix equation. First column is going to represent the coefficients of your first unknown, in this case x. Second column is going to be the coefficients of your second unknown. And then the coefficients of the third. That is our coefficient matrix A. And then we have our vector of unknowns, the vector x, y, z. And our constant vector. There's your matrix form.
How do they know that like a row reduced echelon form is the same? Is it the same thing as the original matrix?
It's row equivalent, not the same.
Meaning, like.
So it just means that it was obtained by performing row operations. They just defined it that way. That's how the definition came about. Right, so a lot of the definitions we work with is they just decided that's what it is. Right, so for instance, row operations were not a thing until they decided to make them a thing. And again, they probably did that based on, let's see if this is useful for equations, and define the row operations to be identical to the operations on equations to get a similar system. We're going to start using row operations. Our first goal, I'm going to use Gaussian elimination. So I'm just going to get into REF form. first. Remember those two operations? That's how we're going to start. That'll be 0, that'll be 0. Oh, good, that's also 0. That's nice. That's a typo. That was supposed to be a 3, not a 2. That's better. Negative 2 plus 3 is 1. 1 plus 1 is 2. Negative 3 plus 5 is 2. Negative 6 plus 8 is 2. 3 and 4 is 7. Negative 9 and 17, 8. Yeah. Makes the next step pretty simple. Negative 2 row 2 plus row 3. Get negative 4 and 7 is 3. Negative 4 and 8 is 4. And then just what? 1/3 row 3? Write the system that this augmented matrix represents. Right, the idea is this system is equivalent to the original system, which means they have the same solution. Z equals 4/3. Now do backward substitution. Plug that 4/3 into the second equation and solve for y. That's what? 2 minus 8/3? Negative 2/3? Take that z and that y, plug it into the first equation to solve for x. Three plus 4/3, 13/3, plus 4/3 would be 17/3. Writing as an ordered triple, that's your solution. That's Gaussian elimination.
What is the S?
Just represents solution set. In this case, single solution. You could write it as a vector as well. Doesn't matter. Gauss-Jordan, we would continue, right? Because we want to get it down to RREF. So we already got to here. What did we have to do now for RREF?
Make sure the row that has the 1, make sure that column has only zeros in it.
What kind of one?
The leading.
Yep, so now zero out everything above the leading one. We do what? Negative 2 row 3 plus row 2, and then row 3 plus row 1. Negative 8/3 plus 2, negative 2/3. Four thirds plus 3, 13/3. And just one more step. Negative 2 row 2 plus row 1. Four thirds plus 13/3. And then the idea again is write out what system that represents. Represents that system. Again, that system is equivalent to the original system. They have the same solution. No backward substitution required. There's your solution. Same thing, right? That's exactly what we got with Gaussian elimination. So again, getting it into REF is Gaussian elimination. Getting it into RREF is Gauss-Jordan reduction. From here, I will be using Gauss-Jordan.
Is that diagonal even though it's augmented?
No, diagonal can only be square. Your coefficient matrix is diagonal, but the augmented matrix isn't.
When we have a quiz or a test, can we use either? Or
Either method unless it specifies what to use.
Does it tell us which one?
I think there might be one that does tell you which method to use. But if it doesn't, if it just says solve the system, you can use any method you want. And there are also questions that don't tell you you can't use a calculator. And so I know there's a question where I say set up the augmented matrix and then solve. And I don't tell you can't use a calculator. I'm going to show you how to do this both on your calculator and in Mathematica. Turn on your calculator for the first time, or if it's been off for a little bit, it seems to never want to decide when it wants to go to the home screen. Get the home screen. Cool thing with the Inspire is it lets you create and save documents within it. Right, so if you're doing a project, for instance, and you want to keep all your calculations in one place, you can just create a new document and save it to that project. It keeps all of that up. For the most part, I just stick with the Scratchpad calculate. Command is RREF, so you can either type in RREF or menu 7 number 5. Then for the actual matrix. Again, there are two ways you can input it. The easiest way would probably be just to go to menu 7 1 1. Augmented matrix had 3 rows, 4 columns. And obviously put in all your entries, enter, done. Just want to see if I remember this correctly. I did. Nice. So to enter a matrix by hand without going through the menus, you want it in brackets, which is control left parenthesis. Row entries are separated by commas, and then a semicolon signifies you're moving on to the next row. So if I actually hit enter, this should just give me that augmented matrix, and it does. So that's how you can do it by hand. Now for Mathematica. Question is it awake? It is, that's nice. The command is row reduce for Mathematica. Notice the capitalizations. Notice also what happens if I don't type it in right. Notice the text is blue. That is reading it as a string, not a command. When it's an actual command, the text turns black. Also, you can't see it, but as you start to type in the command, a list will pop up of possible commands that you want to use. Whatever you're performing the command on has to be in brackets. Now we need the matrix. The entire matrix is in braces, and then each row also goes in its own set of braces. With each row being separated by a semicolon. Is it a semicolon, or it might actually be a comma? I don't think they use semicolons in Mathematica. It's been so long since I've used Mathematica for matrices. Yes, perfect. It is commas, not semicolons. But notice how Mathematica outputs it. Not really intuitive right off the bat. We can fix that. By the way, to execute in Mathematica, it's Shift-Enter. Or hit the Enter on the number pad. Okay, so wrong slashes. There we go. Now it's in matrix form, which is more intuitive. And you'll notice the output changed as well. It says output, and it tells you it's in matrix form.
question. For the mathematics project, does it matter how we like put it in? So like, say I want to put A equals, and then the matrix, and I put like row reduce bracket A. Does that matter? If I just assign A to
What you have to do is you have to do colon equals for A. That's storing A as a matrix. But yeah, you could do that as well. Right, so I could do this.
just the way you did it was like faster. I never like seen that with the double slash. So I was like, okay.
Right, then row reduce A. Then when in matrix form, there you go.
Is that double slash just like it equals? Like, that'd be like equivalent to equal sign?
No.
It's like kind of.
It's
just like
it's just what they're using to symbolize this is how I want the output to look. Because there's also I think it's this. No, it's this here, I think. Or if I do, is it that or is it? No, that doesn't look right. It's definitely this. This would tell you to evaluate whatever is in front of it at x equals 3. Right, so that is just what the language is. That means evaluate. This is essentially saying, how do I want the output to look? Right, just the language. Let's make sure I type this one in right. I did, okay. Like I said, I'm going to be using Gauss-Jordan reduction from now on, and I'm not going to be physically writing out the matrix equation each time. Coefficient matrix, what's the first column?
1, 2, 3.
What's the second column?
-2, -3.
Third column.
4, 5, 6.
And what is that going to be augmented with?
3, 6, 5. Oh.
Don't get ahead of yourself. We will be doing augmented with XYZ soon. And that is even more of a pain in the ass. Because then you got to do row reduction by hand with unknowns. That's always fun. What should the first step be? What should we do first?
Eliminate like 2 underneath column.
How would you do that?
Subtract 2 times row 1 from 2.
Technically, yes, but subtraction isn't a row operation.
Add -2 times row 1 to row 2.
We can do something else in this step.
Can you do negative row 2 plus row 3?
You could, yes. But that would be a separate step, and you'd have to do that first. So you could do that, yes. And then you would have to do the -2 row 1 plus row 2 to still zero out that row 2. All right, for now, I'm not going to deviate too much away from the algorithm. And I may start to get lazy and not draw that vertical line. In which case it's going to be an implied augmented matrix. What does the second row become? I'll start you off. I did the hard part for you.
-7.
I got
I got 1 as well.
Oh, sorry. 2 double negatives.
-3.
That's what I got. And what's next?
-1.
-1. What's the third row?
0.
What's this one?
-2. 3.
Apparently also can't read. Because there's a typo. But whatever, we're going to continue with this system. That kind of looks nice. What will we do next?
-1 half of row 3.
Now what?
3 times row 3 plus row 2.
You like it?
What if you did 2 times row 2 plus row to 0 out the negatives?
You could. That would then make this a what? -6 plus 4, -2. You just have to worry about zeroing that out as well. Which you could do. Be careful going out of order like that, because you can mess it up if you're not careful. Right, but again, you'd have to do that step before you alter row 2 with this operation. -4 row 3 plus row 1 at the same time. And so in general, you don't want to use 2 different rows as your starting row in the same step. This is going to be 0, 0, 1. That doesn't change. 0, 1. That becomes a 0. Negative 9 halves minus 1. Is that negative 11 halves? This will be negative 2. That's 0. 6 plus 2, 8. And then do that. Negative 3 plus 8, 5. And then right from there, again, I don't typically physically write out what the new equation is, what the new system is. From here, I just write out the solution.
5 will be
I think all the arithmetic there is correct.
Should the 5 be a negative 3? It's negative 20. Negative 11 halves times 2.
I looked at the wrong one. That's right. Yeah. I was looking at the 3 halves. So it'd be negative 11 plus 8. Yeah, negative 3. That'd be the solution there. I'm going to call this one 2.8 because that wasn't what question 2 was supposed to be. That's what it was supposed to be. And this one I'm not going to do by hand. One negative 2, 4, 2. 2 negative 3, 5, 3. 3 negative 4, 6, 7. Okay, matrix form, let's see what we get. Oh dear, it doesn't like that. I think what I have to do is do this. Yes. What I did, if you click right over here, notice we have like nesting symbols. So I'm clicking this one here. It's now highlighted. Again, you can't see it, but if you right click, it's going to give you a bunch of options. One of them is convert to, and then gives you some options. I hit bitmap to convert it to an image. Just makes it easier to copy and paste. Just so I can get to there. Now remember, these are augmented. Look at row 3. What does row 3 say?
0 equals 1.
Does 0 equal 1? That is nonsense. For those of you who've had discrete or logic, it's what we call a contradiction. It's always false. That means there's no solution. So the solution is empty. It's the empty set. Right now, logically, here's what happened. By doing this method, we were assuming there was a solution. That assumption led to a logical contradiction. That means your assumption is incorrect. And that's how you can conclude there's no solution. Double check for me. Make sure there's no typo. Because apparently I can't even see a typo when I check. Yeah, number 3.
I think so.
Realize if I find a typo now, I'm going to take points away from your exam grade.
I think that's what it has to be.
And I do allow for negative scores.
Negative scores.
0 is not the lowest. There is no lowest. There's no floor. So you couldn't theoretically get negative infinity.
Okay.
Good luck coming back from that one.
That's an instant drop.
Oh, and by the way, the negative infinity carries through each semester. So your score just keeps carrying through, so good luck overcoming it. Set up the augmented matrix. Actually, before I do that, what's the size of the augmented matrix going to be? Go ahead.
4 columns, 3 rows.
So put that in something by something. 3 by 4. Right? 4 columns, 3 rows. 3 rows, 4 columns. Let's do row by row this time. What's the first row? I'm doing row this time.
Oh,
You're right, that's the first column.
1, 1, 3, 1.
See? I have to keep you guys on your toes. Change it up every now and then. Second row.
2, 3, -1, 3.
And third row.
5, 7, 1, 7.
So let's start reducing. We agree with those two operations? Do we agree with that as your new row equivalent matrix? Good. Should be the next operation. All right, -2 row 2 plus row 3. Yes? That's nice. Good or just stretching?
If you have one of the variables, if it's 0 equals 0, does that mean it doesn't work or it's infinitive?
I'm going to get there. I'm going to put it in RREF first. But yeah, that 0 equals 0 basically just means that equation is meaningless because it's a true statement. So we can get rid of it. One, that's obviously going to be 0, 10, 0. Is that what we should get as the RREF? So for this problem, I am going to write out the equivalent system just to make it explicit what we're doing. Typically, I don't. Right, the first one, x plus 10z is 0. The second one, y minus 7z is 1. The third says 0 equals 0. From logic, who knows what that statement is called? What kind of statement that is? 0 equals 0. The statement that is always true. What was that called? Looks like you were gonna say something.
It is.
It's called a tautology. Statements that are always true are called tautologies. Statements that are always false, contradictions. Since this statement is always true, it tells us nothing. So we can really just ignore it. We now have a system of 2 equations and 3 unknowns that has an infinite number of solutions. That means one of the variables is what's called free. It's a free variable. It can be whatever you want it to be. In this case, you only have one choice, z. Z is your free variable. You can tell that by looking at the augmented matrix, and you go, what column does not have a leading 1? Third column. That means your third variable is your free variable. And if you have multiple columns without leading 1s, the corresponding variables would all be free. So you rewrite each equation to be something in terms of z. So our solution set is going to be a set of ordered triples. Well, I'll pick something for z. I don't want a number, because that would just give me a single solution. I want to write it as an infinite set. You can leave it as z if you want. I typically don't.
N?
Yeah, n works. So say z equals some number n. Then what is x?
10, negative 10.
Right, negative 10 times that number. What is y? 1 plus 7 times that number. And then z itself is just n. Such that n is some real number. That would be your solution set.
So we can leave it as z on the quiz?
You can. You'd have to write it this form, but instead of n, write z. That's fine. Typically, we don't do that because we don't want to use the same variable, but you can. It doesn't matter. All right, so there's also what's known as parametric form. I think your book goes over that. Just move this. Right, then your solution would be 0, 1, 0 plus negative 10, 7, 1 times z.
Would this be like calc-free parametric form or it's different?
Yeah. I mean, it is and it isn't. we're writing as vectors instead of a set of equations, where each free variable is a parameter. And so that would be the solution in parametric form, which your book loves to use a lot.
You're gonna need to use parametric forms on quizzes or tests.
I don't think I required you to do it. I may have. I don't recall. Barely remember what I did yesterday. Wrote the quiz 2 weeks ago. Right, but if it does ask for it, this is just what they want. So when you're given a system of equations, how many possibilities do you have in terms of solutions?
1, 2, skew, infinitely many, or not.
You have one too many.
Skew would just be
So skew is something different, so then you have two too many. I agree, no solution. I agree, one solution. And I agree, infinitely many.
am I thinking skew because of parametric?
You might be thinking of the possibilities for lines in space.
Yeah.
Right? They can be the same, parallel, intersect, or skew. Right? When you're looking at a system of equations, you only have 3 possible outcomes. It could be inconsistent, meaning no solution. Could have just a single solution, or infinitely many. There is no in between. If it has more than one solution, it has an infinite number of them. And there's an easy way to tell if you're going to have a unique solution. What happened when we did the RREF here? What happened to the coefficient matrix?
It's diagonal.
More specifically, it's the identity matrix. Generally speaking, if it's going to reduce down to the identity matrix, you're going to get a single solution, a single unique solution. Actually, not generally. You will always get a single unique solution. Because even if this was 0, right, that just means z equals 0. And then you have what's called the trivial solution, which works for homogeneous systems. Homogeneous is, why did you change? There we go. All these are 0. That's called homogeneous. Trivial solution is 0, 0, just everything 0. That's the trivial solution. We'll discuss that more when we talk about linear independence. So we got one more. System of 3 equations and 5 unknowns. Can this have a unique solution?
Yeah. No, it's not square.
No, it cannot. You're either going to get no solution or an infinite number of them. You have too many unknowns, not enough equations. Right? You would need at least 5 equations to have a hope of a unique solution.
Because it's not an identity matrix. They can't make one.
Correct. Right, the way I think about it is I have 5 unknowns. That means I'm going to need at least 5 equations to tell me what each of the unknowns are. Right? I don't have enough information. This actually isn't too terrible to do by hand. I just don't feel like doing it. So you guys first, put it into your calculator. Try and get a solution. And then I'll do it on Mathematica in a couple minutes.
For the purpose of this question, instead of like x sub 1, you just use a.
You can, yes, but when you write out your
Answer.
solution, make sure you specify.
Yeah.
Right, so if this was, let's say, a five by five, and it had a unique solution, and you wrote down like x, what your variable is equals, make sure you use the x1, x2, x3, x4, and x5.
If they were out of order, like if the variables were out of order, would you put them in order first?
No. You just have to make sure that when you write your equation, like, so for instance, if one of the equations, let's say this was x5 instead of x3, you have to make sure that all of your x5s were in the same column. You don't have to actually make sure they're in the right order, but they have to match up for when you set up your matrix. But then you have to remember how you set up your matrix to tell you what each variable is. GPSs are amazing. It's apparently going to take me 5 minutes to get to this room from where I am right now.
Sounds like the sound.
Must be a distortion in space-time. I'm actually not where I think I am. Did someone get a solution?
Yeah.
So which one was it? No solution or infinitely many? So look at the given matrix, because I think I have a problem like this too, where I give you the augmented matrix and I ask you to interpret it. So again, it's implied, augmented. Do we have a solution to this system based on that matrix? Yes, what? So we're going to have an infinite number of solutions, right? How many free variables do we have? Two of them. What are they?
X4 and
What was it?
X4 and X5.
X3 and X5.
X3 and X5 are the two frees. There is a 1 in column 3, but is it a leading 1? Which means X3 is free. X4 does have a leading 1. I used R and T. Apparently I switched it to S. That's interesting. Right. Or in parametric form, what's it going to be? 21. -7, 0, 3, 0. Plus -1, 2, 1, 0, 0. X3 plus -24, 8, 0, -2, 1. X5. Right. So that first one is just the variables for the coefficients for the constants in your solution. Coefficients for your X3 or R. Coefficients for your X5 or T. Questions on Gaussian elimination, Gauss-Jordan reduction? And let me actually write this up as well. First quiz is also going to be this week. So that will be made available on the 6th.
That's online.
Mm-hmm. It'll be online.
So you just go in and do it?
Right. Yep. And I'll discuss it more on Thursday when it actually does go live. See you Thursday.